Hey everyone, in this video we are going to be talking about types of chemical reactions, but first we need to talk about what a chemical reaction is. So a chemical reaction is the process by which atoms of one or more substances are rearranged to form different substances. So again, the process by which atoms of one or more substances are rearranged to form different substances. So basically, we're going to be putting some things together and then making some different things as well, which leads us to the parts of a chemical reaction. So parts of a chemical reaction. So we have reactants, and these reactants are going to be our starting substances. And then we have our products. And our products are going to be substances formed during the reaction. Okay? And the way that this is going to be set up is that we're going to see our reactants. What we start with is going to be on the left side. Then we're going to have an arrow. And this arrow just means yield, or that it's going to form our products. So I like to think of this as I put something in and then I make something new. So I have my reactants is what I'm starting with. I'm going to form new things during the reaction. And those are going to be my products. Okay, and there are going to be different types of reactions. And so we're going to go through those different types of reactions. So the first type is going to be a synthesis reaction. Now, whenever you hear the word synthesis, you may be thinking of putting things together, and that's exactly what happens in a synthesis reaction. So a generic representation of a synthesis reaction is that you have A plus B yields AB. And you might be like, well, what is that? So a real life example of this would be 2Mg plus O2 yields 2MgO. And now those numbers are just coefficients in front of our elements and compounds. We're going to learn more about that later on. But if I went through and labeled this Mg would be my A, the O2 would be the B, and then I can see that they come together and form AB. So again, you have a generic representation and then a real life example. And then a picture of this would be open circle plus filled in circle is going to yield open circle and filled in circle. Okay, so again, synthesis is just putting two things together, and then we form one substance. Then our next type is decomposition. And when you hear the word decomposition, you're probably thinking of something decomposing, and that's what happens here. So this time we have AB yields A plus B. So a real life example of this would be 2HGO breaks down into 2HG plus O. So our AB breaks down into A plus B. And a picture of this would be our open circle, filled in circle, breaking down into open circle plus filled in circle. So decomposition is the exact opposite of synthesis. So synthesis, you're putting it together, you're forming one substance. Decomposition, you're breaking one substance apart. Okay, then we have single replacement. And single replacement is like what the name says. You're having one thing being replaced. So for example, generically, this would be AB plus C is going to form CB plus A. Now, here, we could have also said CA plus B, okay? Don't get tripped up in that part. If we look at a real life example, we would have zinc plus 2HCl yields H2 plus ZnCl2. And if you notice, what happened is that our zinc came over here with the Cl, and this H got kicked out by itself. Okay, so single replacement, you're going to have one element that ends up being by itself. And also you can see that only one thing is being replaced. So a picture of this would be if we had filled in circle, an open circle, plus a striped circle is going to give us striped circle, filled in circle, plus open. And again, that could have happened with any of our circles. Okay, like they could have rearranged in any way. The key thing is that you have one thing by itself on the reactant side, one thing by itself on the product side. Then we have our double replacement reactions, which sounds like the name. We're going to have two things replacing each other. So this time AB plus CD is going to give us AD plus CB. And again, the letters could have been rearranged. It could have been our AC plus BD, and that would have been okay as well. But a real life example of this is AgNO3 plus NaCl. And now for a double replacement, we would see AgCl plus NaNO3. And notice how here we have compounds, right? We have two elements that are together. Whereas up here with our single replacement, we had elements that were by themselves. They were not in a compound. That's the difference between single replacement and double replacement. And if we look here, what has happened is this Ag came over with the Cl, and then the Na went with the NO3. That's why it's a double replacement. And so a picture of this would be filled in and open plus stripe and open gives us stripe, filled in, plus open. Okay, and then our next type of reaction is going to be a combustion reaction. And combustion is going to be a little bit different than our other ones in that it's CXHY plus O2 gives us CO2 plus H2O. Now, the X and the Y are just representing variables. So you could have any number of carbon and any number of hydrogen. In the example we're going to do, we're going to have CH4 plus O2 plus 2 O2 gives us CO2 plus 2 H2O. Now notice, carbon dioxide and water are your products. That is going to be the case with every combustion reaction. This setup is always going to be the same. You're going to have a something with carbon and hydrogen plus oxygen is going to give you carbon dioxide and water. That is always going to be the case for a combustion reaction. And then the picture for this one, this is going to be fire. So you should associate fire with combustion. Okay? And then our next one is going to be neutralization. And so neutralization has to do with acids and bases. So the generic form of this is going to be HA plus BOH is going to form H2O and then a salt. And that salt is going to be the AB. So HA is our acid. So it will have hydrogen and then something else with it. Our base is this BOH. The B will change, but the OH will stay the same, plus water, and then AB is going to be some type of salt. It's just where the A and the B are coming together. So an example of this would be HCl plus NaOH is going to give us water plus NaCl. Okay, and again, if we look here, the Cl and the Na, those were our A's and B's. Okay, and then we need to talk about, those are our different types of chemical reactions, but then we can also classify based off of heat as well. So for example, exothermic. So an exothermic reaction is a reaction that releases energy as heat, meaning hot. So for example, wood burning, heat packs, so hot hands, whenever you break those, that is an exothermic reaction. If you have ever mixed yeast and hydrogen peroxide together, that gives off heat. That is a exothermic reaction. So I like to think of it as exo means exiting, so the heat is on the outside. And then we have endothermic. So endothermic is a reaction that absorbs energy as heat, meaning that it is going to be cold. And so an example of this is going to be an instant cold compress. So if you've ever gotten injured before, this is the thing that like you break it, and then once you break it, it gets really cold. Also making ice cream is an endothermic reaction as well. So I like to think of endo, inside. So it's going to be cold. Okay. Now, let's do some practice with these. So here are some examples. This first one is BaCl2 plus H2SO4 is going to yield BaSO4 plus 2HCl. And we need to determine which type of reaction this is. So you can either label these. For example, this would be my A, this would be my B, this would be my C, and this would be my D. Now notice I did different letters because I had different elements. And if I come over here, I'm going to see that I have A, D, and then C and B. Or I can think of it as my BA came over here, and then the H2 went over here. Either way you want to look at it. But this one is a double replacement. And I abbreviate that as DR. If we come down to this next one, okay, I see that I have carbon, hydrogen, oxygen. My products are carbon dioxide and water. I automatically know that this one is combustion. And it's because of that carbon dioxide and water being the products. Okay, let's keep on going. Here, in this one, we have an A, a B, and a C. If I come over to this other side, B, A, and C. Okay, I can see that I have one element by itself, one element by itself. So this is going to be a single replacement, or an SR. And I can also think of this with the arrows, as in the zinc is coming over here with the SO4, and then the copper gets kicked out by itself. Okay, either way that you want to look at it. Then our next one, I see that I have a compound as my reactant, and then I have just elements over here as my products. So this one is going to be a decomposition because we have one thing being broken down into multiple things. So again, this is AB and then AB. And then in the last one, we have AB, AB, or we have two things coming together into one. So this is going to be a synthesis reaction. And that is it for this video.